here what you will see is a demo we did at the Genie Engineering Conference in July 2013. So the demo is about a Genie project that we're pursuing right now. So the project is essentially to develop the sort of basic components needed for building a large-scale, high-fidelity emulation environment for vehicular sensing and control. So what we're demonstrating here is essentially the capability to sense vehicle operation state in real time, and then potentially this data can be used to drive emulation of vehicular sensing and control networking. So actually road transportation had a lot of challenges today in terms of safety, efficiency, and so on. So there's a question of how can we change the transportation system so that we can have a safe and green transportation. As part of the effort to address these challenges, so both the research community and the industry have been trying to develop solutions that leverage networked vehicle control, both the safety and fuel efficiency. So, but then one challenge in the research of vehicular sensing and control networking is the lack of large-scale, high-fidelity evaluation systems to evaluate innovative ideas. The reason for this is huge cost of deploying large number of vehicles on road for experiments. Unlike wireless sensor networks where we can easily deploy hundreds of nodes for experiments, it's pretty challenging to actually run hundreds or thousands of vehicles in real time and on demand for research evaluation, for the purpose of research evaluation. One of the projects we are pursuing right now is to build the components that can be used to enable high-fidelity at-scale evaluation of vehicular sensing and control networking solutions. Part of the component would be how to get live vehicle data, both the operation data and channel data, into a simulation environment. So what we are demonstrating here is sort of some of the capabilities we have built out of a Genie project. So the demonstration setup is the following. We have vehicles running in Detroit, Michigan, and then we have facilities to sense the vehicle operation data such as speed, distance traveled, fuel consumption, and then transfer those data in real time to a site in Madison, Wisconsin. Essentially, the car in Detroit is connected to the Genie backbone through a Genie WiMAX network deployed on the campus of Wayne State University. And then from the Genie backbone, the cars are connected to the experimental site in Madison, Wisconsin. So here's some of the pictures on the setup of the vehicles on the campus of Wayne State. As you can see, we have a laptop here that's connected to the CAN bus, the controller area network bus, through a vehicle interface, OpenXC. Accordingly, this laptop can get to access all the messages that that are exchanged within the vehicle system between different sensors, controllers, and so on. Our students are driving the car in real time, and then we essentially stream the sensing data from the running vehicle to the Wisconsin site. Here's the demo site at Madison, University of Wisconsin-Madison. Here's how the demo look like. So remember, we have a vehicle running in Detroit, and then here's what an experimental may see at the experimental site in Madison, Wisconsin. So we have 3 screens here. The large screen is used to demonstrate the vehicle sensing capability. We'll get back to the details a little bit later. Then we have this the black laptop in the middle, which we'll also talk about in more detail. Essentially, this shows the WiMAX channel data. And then we have a third iMac Pro laptop here, which basically shows the street view in Detroit. Now, so here's a screen which shows the raw measurement from the vehicle, and then from there you can see a lot of data, including For example, if you can look at the screen a little bit more careful, including vehicle speed, the steering wheel angle, the engine speed, the fuel consumption, the accelerator pedal position, and so on. So essentially from through the OpenXC, you can get to see a lot of internal data for vehicle, and the data is updated fast and in real time. So as you can see, with our infrastructure, the live data, sensing data, can be streamed to an experimental site in real time, and then this data essentially can be used for all kinds of purposes, ranging from building models about vehicle operation to driving the NS3 simulations of vehicle network or networked vehicle systems. And then this figure shows the channel behavior from the vehicle to the WiMAX base station we have on the campus of Wayne State University. So here we showed two data. One is RSSI and CNR. So you can see it's mostly stable, even though it kind of oscillates. And then we have the larger window, which shows the fuel economy. Basically, what we did is we get the fuel consumed over each specific period of time or distance traveled, and then from there you can get to you can compute the samples of fuel economy, which is shown through the blue line here. As you can see, there's actually quite some noise in the measurement, but if you smooth it out, you actually get to see the average fuel economy. And then you can relate this fuel economy with other parameters such as the speed of the vehicle and so on. So conceptually, with this data, if we imagine that every vehicle get equipped with this equipment, you could have a lot of the data streamed back to the backend server, and then you can use this to build models for vehicle design, or you can also use this to drive simulations of vehicular sensing and control.